The PLABEL package is a series of Delphi components available for VCL and FireMonkey that allow us to include a graphical editor in our programs. It uses the Skia library for rendering graphics on both platforms, a library included in the latest versions of Delphi. The initial purpose of the components was to include a label editor in Delphi programs. Starting with version 3.0, which was completely rewritten, 2 more editor modes were added, one for drawing flowcharts and another for technical drawings. Depending on the editor mode, different units of measurement are used and different elements can be added. Some properties dialog boxes also change. When in labeling mode, we can link tag elements to various data sources, descendants of T datasets, CSV files, or JSON files, which we can store within the label file itself. In the case of CSV files, we specify the column separator, whether the file includes a header, and whether the text strings are enclosed in single or double quotes. Another feature we can use when working with data binding is the ability to specify an integer field in the table. CSV file or JSON file. This field indicates how many times we want to repeat each label with the data from that record. In the preview, we will see the labels and their repetitions. One of the elements we can insert into the tag is a table, where we link to a detail table. This can be a master detail linked T dataset or a JSON file with arrays of records within other arrays, specifying the various columns and the fields they link to. We can also include a footer with the result of an operation performed on the records. We have numerous elements available for insertion in the editor. Text, click where you want to insert it and start typing in the editor itself. It offers numerous properties such as font and styles, horizontal letter scaling, text angle 0, 90, 180, or 270 degrees, background color or rounded edges, and horizontal or vertical spacing around the text. Apart from changing the angle, we can align the text element horizontally and vertically to different positions. Another element we can use is the paragraph, which allows us to insert multiple lines of text, defining the text alignment, rotation angle, and horizontal and vertical padding. This element can also be associated with a data record. Circles can be inserted in several ways, by specifying their center and radius by specifying 2 points, or by specifying 3 points. To position the points, we can activate the available snap options. In this case, the grid and snap options are active. Another element we can insert is an ellipse, specifying the measurements of its major and minor axes. In the editor, we can draw lines, and by activating the orthogonal mode, F8, we can make them horizontal and vertical. When drawing polylines, we can add points to an existing polyline by right-clicking on the point we want to add, and when we select a point, we delete it with the delete key. Another element that can be added is Bezier curves. We place points through which the curve will pass, and the tool adds the control points. The Bezier curve can be marked as filled or unfilled. To display a position rank using different shapes and fills, we use this element. The possible shapes are square, circle, star, and diamond. It can be displayed horizontally or vertically. Another element for indicating a percentage as an occupied area is the level element, which can also be linked to data to display the value. There are different styles available for displaying the percentage and formatting its output. To add an arc, we specify 3 points it must pass through. We can then modify the arc by changing the position of these points. At the beginning and end of the arc, we can place different shapes. If we want to mark a circular sector, we use this element. We can indicate the angle that the sector will occupy, as well as the initial angle from which we start drawing. When inserting an image, we have the option to include it in the tag file itself or not. So we don't depend on paths and folders on other computers. We can apply different formats and filters to the images to modify their appearance. One specific element of the food industry that we can use, although its implementation is not widespread, is the Nutri-Score symbol, which is used to label a food product with letters and colors indicating its nutritional value. When we include it on the label, we can modify its appearance, colors, the value displayed, and whether it's black and white. The package element is used to represent the 2D or 3D dimensions of a shipping package. Its properties include the box's dimensions, color, font R size, and several different display styles. With or without text. In addition to representing a table or box, this element can also be used to depict holes, position and size, and grooves to be cut when machining boards for furniture manufacturing. The arrow line element is used to draw a line with the option to define shapes at its ends. These can be circles, squares, crosses, or arrows filled or unfilled. This element can also be associated with data to represent its value as text. Options include setting the value itself or using the line's length in the drawing's units. The label editor also includes elements for representing one-dimensional barcodes, with numerous properties such as bar height and width, bar color, background, margins, whether or not to display text, and more. We can link it to data by assigning its field, and we have different types available, such as Code 39, Code 93, EAN 8, EAN 13, UPCA, EAN 128, and others. We can also insert 2D barcodes, including Datamator XI, QR, and PDF 407 codes. We can also set background color and margins, as well as the size of the bars. Other properties we can assign include code alignment. To draw text with various formats, we can use the polytext element, where we add several text strings, each with its own format. The horizontal and vertical alignment of the text can be assigned. As well as the margins around it. Individual text elements can be linked to data. The combined text can be displayed as barcodes of different types, EN 128, QR data matrix, with the option to assign application identifiers, AI, to each segment. In the latest version of PLABEL 3.1, the rich text element has been added, where through different tags we can change the properties and format of a text. When working in labeling mode, we can use the editor for one-page reports, as in this example where we design an invoice, which we can link to data including JSON stored within the tag itself. We see how we use the table element linked as detail data to display multiple data records. Both the VCL and FireMonkey libraries include a complete example demonstrating the functionalities of a tag editor, with several representative examples and links to data. In flowchart mode, we have access to the commonly used shapes and various connectors. We assign start and end shapes to the connectors for each line. We also have a complete example editor for VCL and FireMonkey. One of the most interesting features of this editor is the ability to create symbol libraries. Symbols are created by assigning them a name, an insertion point, units of measurement, and a series of drawing commands used to represent them. Drawing commands can be of many types: lines, circles, text, polylines, arcs, etc. Their properties, color, line size, style, etc. can also be modified programmatically. This process is carried out through code. One or more symbols can be added to a library, and finally, it is saved as a file. The symbol folder, library folder, is assigned to the TMP label component so that each time a symbol is inserted, the selector will open with all the libraries and their symbols found in that folder. When we insert a symbol, we can assign its insertion point and angle. The units of measurement are important so that the symbol fits our drawing. We can also add connection points to the symbols, indicating their position in the creation of the symbol through code. These link points allow us to connect different symbols to each other and drag the link when moving the symbol. When in Technical Drawing Editor mode, we can draw dimension lines on the figures in the drawing, which will represent the indicated measurement. There are also dimension lines to indicate diameters or radii of circles, as well as a dimension for the angle formed by two lines that we specify. When we add dimensions, they are assigned the dimension style that we have active. We can open a style editor that allows us to modify the properties of the current style and add others. The properties of a style include the line color, the size and shape of the terminator, the line spacing, and the font used. The editor allows you to define a list of layers. Elements you insert will be added to the currently active layer, inheriting its color, background color, font type, and size. Layers can be made visible or hidden, and can also be marked as printable or exportable. We have numerous drawing tools at our disposal, such as the ability to draw figures equidistant from the selected ones at a certain distance, which can be defined by marking on the editor or indicating its separation by keyboard. Other tools to help us in drawing include the ability to extend lines to a reference, trim lines from a line, and join two selected lines. The latest version adds the ability to load a map image from an online service, specifying the service, the zoom level, the coordinates of its center, and whether to draw a crosshair in the center. Additionally, you can define the image's margins along the page edges. When loading an image, you can assign the map scale according to the chosen zoom level. This map image can also be assigned to an image placed in the editor. As with the other editor modes, the technical drawing mode also includes a complete demo, where you can test all the features and open several examples. In this mode, you can set a drawing scale that you will use to draw figures and measure distances. In this demo, you can click on a Generate by Code button that allows you to draw all the figures using written commands. Besides previewing and printing, we can export as PDF, PNG, JPEG, GIF, and SVG. SVG is a perfect tool for showcasing our designs on the web. Examples can be found at https://www.majurasoft.com PLABEL Gallery. The editor files can be saved in binary format or as JSON. JSON is a format that AI understands very well. Therefore, if we provide it with an example containing several saved figures and ask the AI to produce a drawing, current models will be able to deliver a JSON file that we can load into the editor. For the next version, we will add a new component, MCP server, which will have the necessary tools to configure the editor in paper size, measurements, scale, and to tell it to draw figures on it.